All right, so I'm Sam, and I wanted to take this opportunity to show you a side project I've been working on for some time. It's actually an AI chatbot for the Dagger documentations. It aims to provide another interface to learn about Dagger. Instead of searching for the docs, you can basically ask a bot. It was also the opportunity to learn about the pain of writing an AI app and see how AI developers feel day to day. And so took the opportunity to see what we could improve along the way. So I'll dig into that as well and show you a demo of the app itself. Well, first of all, this is how most people think it is to build an AI app, amazing, magic technology, at the touch of your keyboard. The sky is the limit. But how it really is actually is more like that, at least from my experience. You quickly end up with a stack that's very brittle because you have to manage a lot of different things, and a lot of different things in your pipeline can fail. So pretty much managing the assets is key. And so I'll dig into the things that I faced. Well, first of all, that I had to build a pipeline that looks like it. So even for a simple app, the pipeline is getting quite complex pretty quickly. I basically had to fetch the documentation source files from the Dagger Git repo, sanitize the documents, strip characters, split them into text chunks, tokenize the chunks, embed them using a model. It's basically creating vectors of numbers from text, store those vectors in a vector database, and also pull the weights of the model itself that I want to use. So in that case, actually, I used Llama 2, and the entire app runs locally on my machine. It doesn't use any remote API. It's not using OpenAI or anything. And this pipeline, actually, the challenge is that you have to rerun it. Every time the model is updated, the documentation is updated, or if you want to update dependencies of the app itself. And ideally, also, given that this app is open source, you want other people to contribute, try it on their machine, and just also run it so they can change some code and submit PRs. So that ideally, you want this pipeline to be portable. So the pipeline that I just described, this is what it looks like in an architecture diagram. So you have pretty much the docs, which is the input of the pipeline. Then you have fetching, sanitize, tokenize, split, embed, and store the vectors. Along the way, I used actually LangChain and Hugging Face, a model from Hugging Face for the embedding. And then storing the vectors into PromaDB, which is a vector database that's pretty popular nowadays. And then you have the chatbot itself, which basically consumes the vectors in the database and then interacts with the model. In that case, actually, I use something called Ollama. That's a project that I like. It provides an abstraction on top of several models. So again, I could actually swap to different models quickly to try the different results. And for that part here, basically the big square here, this is where I use Dagger to pretty much containerize my pipeline and make sure it can be rerun anytime I want. Results are cached also, because the first time you run this pipeline, it's pretty heavy. But I will show you right now, if there is nothing that needs to happen, it's fine. It's pretty fast. So the Dagger figures out what needs to be rerun or not. And I will also give you a quick look at the app itself. And all right, demo time. So this repo, by the way, is open source. It's available. There is a small README with few instructions how to use it. So now I will switch to my terminal and show you some fun stuff. All right. Let me know if the font is too small. Ideally, it's readable. So first, I will show you I will show you the app itself. It's actually the funny part. So keep in mind that it's actually I'm using a method called RAG. So basically, I think it's the acronym for Retrieval Augmented Generation. So I actually consume vectors that were generated from the Dagger documentation, and I embed that in the prompt that I'm providing to the model. So in this case, for instance, I will, I don't know, ask the bot about something I would search for in the dark, or I would typically ask on Discord, for instance, how to integrate Dagger with GitHub Actions. So it's a question that we get often. So in this case, the inference will take about usually around 10, 15 seconds roughly. So basically generated the prompt by building a context from the documents that it got from the vector DB. And also the prompt has some extra context to restrict the model to answer about Dagger only using the context. So it's very it's a popular method that is used for actually this kind of chatbots. I see I have some encoding issues that I have from time to time. I'm not exactly sure. I need to debug that. But here I see the result. So to integrate Dagger with GitHub Actions, you can create a workflow file in your repository, GitHub workflow, define steps. Even gives me a snippet of that I could reuse. Usually snippets of code are more or less accurate. It really depends on the questions and the complexity that you ask. It also depends on the quantity of examples that we have matching in our doc. So more snippets of code you will provide, and the better it will be. Let me try something a bit more, I would say, that requires more than a search, actually. That requires some triaging of information. How does Dagger compare to Terraform? It's actually an interesting question, because we get this one a lot. While it uses the inference, well, what we usually answer is both tools are complementary, and we use Terraform for managing the infrastructure and Dagger for the pipeline itself. So it's interesting. By the way, the result is always different because there is some level of randomness in the answer. So here I see Terraform is an infrastructure as code tool that allows to define infrastructure in human durable format, provision, manages infrastructure resources, etc. Interesting. And Dagger programmable CI/CD engine that runs your pipeline in containers. It allows to develop your CI/CD as code in the same programming language as your application, blah, 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 blah. And in summary, Terraform is focused on infrastructure provisioning and management, while Dagger is focused on CI/CD pipelining and containerization. It's very, so yeah, this one is pretty good, actually. So yeah, you can see the idea, and we cover a bit of that question in the doc. Sometimes you can even ask some questions that require knowledge that are not in the documentation. And this is where it gets interesting, because obviously the model is pretty massive. It has, well, this one is the small version. It has 7 billion parameters, but it has some context of technologies out there already. So now I will show you how to run so first I'll show you how to use the app. So the app needs assets to be generated. So this is the vector database that I mentioned previously. And the vector database is actually generated from the Dagger pipeline. So if I run basically the pipeline itself, it should be pretty fast, actually, except if something changed in the documentation. But given that no change were made in documentation since last time I ran the pipeline, everything is taken from the cache. The interesting part here is actually I can even remove the assets. So now the app is technically unusable. I rerun the pipeline. It executes as fast, and boom, I have the assets again. Basically, they are generated from the cache. I can quickly show you what the pipeline looks like. What I wanted to achieve also with this pipeline is make sure that if you're interested to look at the code, try it yourself, and even have a dev environment that you can really spin up on your machine. You just have to do this Dagger run with the pipeline, and boom, you have the assets needed. You can use the app, modify it, and look at the code, etc. So here I have all the steps that I described before, a few scripts to sanitize the docs. It basically runs another script, smaller script from inside the container. That's the code that split and vectorized the documents to the vector database. It exports the assets on the local file system. I'm using also the Dagger Python SDK. Yeah, and that's about it. Not sure if we have time for questions, but can also play with some other fancy prompt if you want.
There are
Thank you.
a few questions on just kind of how far it can go. Can we get URL references to get the docs in context?
I actually stripped the URL on purpose. So this is really a part that is getting interesting because this is a foundation right now. It works, it's functional, but it can go really far in terms of accuracy. Basically, you can tweak. So the simple answer is no. I actually decided to strip down the URL to not have any URL reference, but technically you can actually. You can technically keep the URL in the documents and ask the model about the URL specifically because it knows what a URL is and can fetch it. Problem is, if you end up with a document that doesn't have the right URL and you ask for it, this is where, well, ideally you want the model to be configured to reply, I don't know, I don't have this information, instead of making up with a fake URL, obviously.
And then let's finish with one more question. Is it possible to run this out of the box and point to any docs repo?
Yes, actually, yeah, the code is not really specific to Dagger in that case. Well, there is some parts that are specific. It's pretty easy to fork and adapt to your own repo. It's pretty much like a standard RAG application. So yes, you can take this pipeline and adapt it to your own docs. There might be a few steps in the pipeline specific to the Dagger docs right now, but it's really easy to replace.